All right, let's jump right in. There's something your body is doing right now that you probably never think about, and it's literally a matter of life and death. It's dealing with its own toxic waste problem. Yeah, you heard me. There's a silent, microscopic war being fought inside you every single second just to keep you safe. And that leads us to the big question. You know that chicken breast, or that egg, or that protein shake you had earlier? Well, the moment your body starts breaking it down, it creates a poison. So the real mystery isn't that it happens, but how in the world your body manages to get rid of it without, killing you. And this poison? It has a name: ammonia. And let me tell you, this stuff is seriously nasty. Picture a corrosive chemical. If it starts to build up, it throws the pH of your body fluids way off, making them so alkaline that your cells just stop working. So the body has to get it out, and it has to do it like right now. But how does it do it? Well, evolution is pretty clever. It didn't just find one solution and call it a day. Nope. It actually tailored different strategies for different animals in different environments. Let's take a look at nature's 3 main game plans for handling this universal toxic threat. Here's the catch: the fundamental problem every animal has to solve. To safely flush out something as toxic as ammonia, you need a ton of water to dilute it. Now, if you're an animal living in the ocean, that's no big deal, right? Water everywhere. But if you live on land, that's a huge, huge problem. So nature came up with 3 distinct blueprints, and it all boils down to one thing: water. If you live surrounded by water, like a fish, you just dump the highly toxic ammonia straight out. Problem solved. But on land, that would be totally reckless. You'd dehydrate in no time. So mammals, like us, actually spend energy to convert that toxic ammonia into a much safer compound called urea. But what if you're a bird or a desert lizard and you need to save every last drop? Well, you spend even more energy to create uric acid, which is basically a thick paste that needs almost no water at all. It's this perfect evolutionary sliding scale. The less water you have, the more energy you gotta spend to stay safe. So, you see, as animals started to conquer the land, the pressure was really on. The old just add water strategy just wasn't gonna cut it anymore. They needed a new, water-saving chemical factory. And lucky for us, the one inside our bodies is an absolute masterpiece of engineering. So let's zoom in on us, on the human solution. It all happens in this incredible organ, the kidney. It's a super sophisticated filtration factory that takes care of our ammonia problem by turning it into urea. And if you want to really appreciate how hard your kidneys work, just look at this number. Every single day, your kidneys filter about 180 liters of fluid from your blood. That's like, 90 of those big 2-liter soda bottles? It's just a staggering amount of work happening inside you as we speak. So where is all this filtering actually happening? Well, it's not in the kidney as a whole organ, but in about 1 million tiny microscopic filtering units packed inside, called nephrons. You can think of each one as its own little factory, complete with plumbing, pumps, quality control, all of them working together at the same time. Making urine is basically a 3-step process of cleaning your blood. Honestly, the best way to picture it is like cleaning out a really messy drawer. Okay, step 1, filtration. This is when you just dump everything out onto the floor. The good stuff, the trash, all of it. In the kidney, that's when water, salts, sugars, and waste all get forced out of the blood. Step 2, reabsorption. Now you have to go through that pile on the floor and put back everything you actually want to keep. And your kidney is amazing at this, reclaiming over 99% of the water and all the useful molecules. And finally, step 3, secretion. This is the final check, where you spot a few extra bits of junk in the drawer and toss them out onto the pile. The kidney does this too, actively pumping out any last bits of waste. So what's left on the floor? Yep, that's urine. Okay, now we're getting to the most brilliant part of this whole system. Getting all that water back isn't easy. It requires this incredibly clever piece of biological engineering called the countercurrent mechanism. Sounds complicated, but it's actually beautiful. And this question really gets to the heart of it. We start with 180 liters of fluid being filtered, but we only pee out about 1.5 liters a day. So what happens to the other 178.5 liters? It all gets reabsorbed, and the way the kidney pulls this off is pure genius. The secret is this U-shaped tube called the loop of Henle, where 2 totally opposite things happen right next to each other.
As the fluid goes down one side, the tube is basically like a sieve for water. Water just leaks right out. But then, on the way back up, the walls of the tube suddenly become waterproof. And not only that, this side starts actively pumping salt out into the tissue around it. So you've got water coming out on one side and salt being pumped out on the other. This simple difference is the key to everything.
And that right there is the counter-current trick. Because the fluid is flowing in opposite directions, the salt pumping happening on the upside creates this intensely salty environment for the downside to pass through. This super salty zone acts like a powerful magnet for water, just pulling it out of the tube through simple osmosis. It's an incredibly smart, low-energy way to build a powerful water reclaiming engine. And here is a beautiful example of how an animal's body is perfectly suited to its environment. The longer this U-shaped loop is, the more powerful that salt magnet gets, and the more water can be pulled back into the body. So it's really no surprise that desert animals like camels, who are the true masters of saving water, have evolved kidneys with incredibly long loops of Henle. It's how they survive. This whole system is a biological marvel, it really is. But it's also pretty delicate. So why does any of this matter to you and me? Well, because when this complex filtration factory starts to break down, the consequences can be incredibly serious. When this system starts to fail, big problems can follow. If the tiny filters get inflamed or damaged, that's called nephritis. Waste starts backing up in your blood. Too much urea in your blood leads to a dangerous state called uremia. Sometimes, minerals can form tiny crystals that become excruciatingly painful kidney stones, and in some cases, uric acid, yep, the same stuff birds make, can form sharp little crystals in your joints, causing the intense pain of gout. It just goes to show how critical this silent system is for our health every single day. For people whose kidneys fail completely, their lives depend on an artificial kidney. A dialysis machine has to take on that massive job of filtering the blood from outside the body, removing all the waste that the body's own system can't handle anymore. It's a true lifesaver, but it's also a really demanding process.
So we'll end with this thought. Inside you is this amazingly sophisticated, elegant, and absolutely vital system, working tirelessly 24/7 to solve a constant toxic waste problem. And it does all this without you ever having to think about it. So the real question is, what are you doing to protect it?